Good morning friends. In this class in C programming, today I am going to cover about structures, and we will cover specifically about basic of structures with a live demo. So what is a structure? How do you generally define a structure? It's basically a collection of lots and lots of programming variables which are attributes of an object. Structures can be a homogeneous collection or it can be a heterogeneous collection. Homogeneous means the data types, the variables are of same type. Heterogeneous means variables can be different. Why do we require a structure? We want to represent real world objects in our programming. For example, if you have an employee or if you are a student, all of these employees or students are an object. We want to have lots and lots of attributes for them. For example, if you are a student, what's your name? You are in which college? So college name, your department, which branch you study, which year you study, and then your overall marks. So those are some piece of data which belongs to you as an object, you as a person, you as a student. So when we talk about structures, right, so we are really trying to organize the real world data and we can group them into a related variables. So when you say variables, it basically means that what are the data types you might want to assign. Name can be a character string. So name is a character string. Department can be an ID. ID can be a string. ID can be an integer. Your overall aggregate marks, that can be a floating point number. So the idea is, you can have lots and lots of attributes which are part of the object. So structures allows us to organize them. We can create a structure called student, or we can create a structure called employee, and then we'll treat them as a single unit as far as our programming is done, right? As far as our programming activities are achieved on those structures or on those real world objects. So in a sense, when we talk about declaring a structure in C language, we are defining a new data type, because C language has primitive data types and user-defined data types. In user-defined data type, the first thing it allows us is to create a new structure. So we are really creating a new data type. When whatever we write inside the structure definition, we are basically creating a blueprint for that. It's a template. It's a template for our current student or an employee structure. And the C compiler fully understands it and sees that it's a new user-defined data type that we can use in our program. So we can have lots of structures that can be created depending on the programming assignment on hand. So in a sense, we can say that it's basically a mechanism of adding new data types for the C programming language. So how do we generally define a structure? In programming, we always prefix a keyword called struct. So we use struct keyword for declaring our structure. Once we declare a structure, we can define an object or a variable for it. So let's look into some examples of a structure. I am going to cover two examples from day-to-day life, which is like a user space programming, as well as example from a kernel space. Okay, so we'll talk about two things, user space and kernel space examples. So as I indicated before, in user space, when you see, everything is a database. Employee record, employee database. Student record, student database. Railway reservation system, bus reservation system. So you're reserving a bus ticket or a train ticket. So there also you have to add lot of attributes. So what are some of the attributes? We can have attributes for an example as an employee. You can have the name of an employee, the address of an employee, department, designation, salary, and so on, right? So these are an attribute. So which means every employee will have these attributes for a given organization. How do we translate it down in our programming world in C? We can have a definition called struct employee or EMP, and then in that we can have an employee number which is an integer. Or you can have a name which is an array, or you can have a designation which can be an array. And similarly, you can have a salary, which is like a floating point number. So in essence, what we are doing is we are mapping a real world object, a database object or a database record in terms of a C language construct known as a struct, right? So these things we keep on doing day in, day out for every application that we design actually for implementation in C. However, if you really would want, we can also do a same thing. So let's look into Kernelspace. Okay. Now Kernelspace example, I will give you a live demo of a kernel source code, and we'll take a very commonly used object. So what is our object? A commonly used object will be a file. So all of you know, whether you are using a C, whether you are using a Windows or a Linux system, we always open a file, we always create a file, we modify a file. File has owners. File has a size, right? File has permissions. So file is a very common object, and we can see them how they are written as a structure. At least we can see them in the kernel source code. So this is a common code which we can easily work upon and then try to see them. Okay. So when we look into that, let's go into a small demo for a kernel code. The goal here is not to learn the code. The goal here is to see the file as an object. Before I do, let's just understand what is the file I am talking about. Okay. See, this is a Linux system in which I am doing an ls long listing on my home directory. You will see so many files are there. Each of these files have different have attributes. You can see on the left hand side. Okay. So this is one way of getting the data for a file, ls-l, right? These are the attributes. Attribute says this is a directory file, and this is a read, write, execute permission, and then read and execute and a read and execute. 16 links are there. User ID is Bhojas, group ID is Bhojas. This is a potentially a size, and this is a timestamp. For every file, you have a different values for them. You can see that. So now here a file is an object for us, and when you implement it into a kernel, this file are represented by a structure. In the kernel, every file is represented by a structure. So let's look into the kernel source code now. So in the kernel source code, we will see this structure. To understand the structure and how it is shown or seen. Okay. So the name of a file that we use is known as a struct file. Okay. So I'm just trying to do a global definition search and we will arrive at the definition of struct file. So I'm just trying to search. So the file of interest is this one, because this is the one which is the global implementation of a file as a structure. So let me open this file. So once we see this, you can see this is structure. Let me pull it up. So when you see this, it's a struct file. Now a struct file has lots and lots of members. Some of these members are difficult to understand. Our goal is not to really understand the struct file, because that's the area of kernel development. When you are focusing as a kernel developer, then you have to understand each and every field actually. Okay. Yeah. So some of the fields of some of these members of struct file is what I am going to show you now, which we can relate to our file as an object, right? So when you do an ls command or ls-l command, you will see some of these details. So let's come back and try to see. If we focus more on this, we will understand that who is the owner of a file, right? And similarly, the mode. This is exactly the mode which are associated with a file. We call it read, write, execute, chmod operations, right? To read, write, execute. So these bits are stored in the mode field. Similarly, you have a flag. What is the meaning of a flag? Some of you who are doing C programming, you will see that we do an open system call or an fopen. We open and then we say open read only, open read write, open write only. So we have lots of flags. So whenever we open a file with a specific settings, that's get stored in this, right? So you get a mode, you get a flag, and then file operations, right? So it's a file operations. We do a read operation, write operation, seek operation, so a lot of operations. So what you see in summary is an implementation of structure which covers the attributes and operations on a file, right? So I think this is what I kind of wanted to show you in this particular exercise. So let's go and move back and come into the class, into the slides to understand more about structure, right? So when we see we have structures where two examples have been discussed. So we will move forward in terms of structures. Now what else we can see in structures? Structures is slightly more involved because lot of details are there in structures. We have the concept of padding. We have a concept of structures and how do you pass them in a function. And then arrays of structures, pointers to structures, self-referential structures. Okay. This data I am going to cover more detail as a separate slides because as a separate videos because we have not introduced the concept of arrays and pointers at this point of time. So in this class I am going to cover basics to really get a good understanding about structures. And then in subsequent videos I will cover each of these bulleted points exclusively. So let's move on with a small lab demo. This demo has been created by me and we will do it's a live demo. Lot of users have given me comments saying that they wanted to see a complete live demo on a structure, usage of structure. So this is going to be coded by me from scratch in this live presentation now. So we are going to introduce structure in C programming as an example and we'll do lot of operations. Okay, so we'll read the employee data from a standard input and display the data. We are going to display the address of the memory allocated for the structure. So this is useful because we need to know where the memory is coming from by the compiler. Okay, and I will show you two variations: memory coming from the stack and memory which is coming from the data segment, right? So we will just try to see and we will see the pattern on the memory. So this is very interesting. Good programmer in C, they need not look into the code. When they look into the output of a crash or some debugging, they will come to know this memory belongs to, or these variables or this data are coming from either stack or a code or a data section or a heap, right? So this is interesting. Then we'll also cover the memory which is allocated in terms of sizes for this entire structure. Now this is a simplified example. Sizes is a slightly more complicated, complicated item to arrive at by looking at the structure because structures are very big sometimes and we have a concept of structure padding, right? So here we will talk about the size of individual members of a structure. And we'll also talk about the overall size of the structure. So let's get into the demo. So it will be like a live code on sfstruct.c as a demo. So we will do a demo as a live demo. Okay, so we will have sfstruct.c. So this is the implementation. We always should have some blueprint for our program. So while I'm coding it, I'm also giving you some guidance about how do you arrive at, how do you code much more efficiently. You can have templates for your program if you want, if you are coding a lot of programs on a day-to-day basis. Even otherwise also you should have the way to code. So the standard way to code is always write first the empty definition of a function so that we know we are into a particular function, and then we are going to start coding inside this. our assignment here was to work on a structure. So we'll create one structure. So I'm just making a structure definition global. Okay. So this is a structure. We'll call it as employee. And then this for structure, we are going to add. What we are going to add, we will have attributes. Employee have an attribute, say integer. Employee. So we can have employee ID. That is one of the attribute. Similarly, you can have another one which is simple, known as employee name. And then for the sake of this class, we will say the name as 30. So this is how you are slowly building up your program. Okay. And once you have started working on it, you can always make sure that your program compiles. Okay. So you can always save the file, always compile it. It's not mandatory that you should compile towards the end for a lot of people who are beginner. Okay. If you are already a professional coding a lot of details, but it's okay that you can compile at the end. But the goal is you should always do a step-by-step operations. Okay. Right now we have declared a structure, defined an object. I can compile it if I need, just to understand whether my coding is fine, because as a beginner I need to understand whether my syntaxes are fine. Okay. If you do a proper coding, and if syntax is good in the beginning, right, you will have less errors in subsequent lines. Okay. Otherwise you have to change a lot. Okay. So this also allows us to do some amount of disciplined programming. So let's compile this code once actually. Okay. So we will do a compilation. So we will say cc sf struct.c. Okay. So yeah, compilation went fine. I don't have problem. I can run it, but there's nothing as an output in this program. It is just a structure object. So let's go ahead and try to write our code now. Okay. So first thing is we want to read, as per our original assignment, what do we want to do? We want to read the employee data from the standard input and display. Right. So this is what we want to do. Later we'll talk about the memory in terms of address, and then the memory in terms of size. Okay. Yeah. So this is a step-by-step approach. I repeat, there is nothing special about it. So let's go ahead and do a printf. Okay. Why a printf? Because when we run this code, we need to display something on the screen so that we know what is expected by the program. So we will say enter the employee number. It is pretty simple, right? So we do an employee number, and then we have to also do and enter the employee name, right? So the first one is scanf, and then you have to supply what you wanted to read actually, right? So it's a employee number is an integer value. Okay. So we have to do %d here. E is an object, and then in that object or a structure object E, we want to read about employee ID, right? So this is what we are going to do. Now, as you know that scanf, whenever we read a data, it expects an address. Okay, so we are going to do a ampersand in C language, right? So this is scanf. So this is first part. Similarly, employee name is basically always a string, right? It's a string, %s, because it's a name. When you have a string, we have to say employee name. So you're supplying the array. When you supply the array as an argument, we are essentially passing the address of the array, the first element of the array, right? So no need to supply an ampersand. Even if you supply an ampersand, it's just same. The name of an array is as same as an address. Ampersand of that is also same. Okay. So we are reading it like this. Once we have read it successfully, then we are going to display the data. So what do we want to display? We'll say printf. So here we have to now really displaying, right? So we say employee employee ID is %d e dot emp ID, right? So this is an employee ID, and second one will definitely be a name. So we are talking about name here, right? So name is always %s, and then we can say employee name. Again, we have to make sure that the code is fine. So it's always good to save it, and then we do our CC. Yeah, so compilation looks fine. Let's see when you run the code. It says enter the employee number. I'll say 100. Employee name Manish. So employee ID is 100. Employee name is Manish. So far the code is good. Okay. So this is what is the simplicity. We have to always make sure that when we code, we should code for excellence. Excellence generally also means that try to write a very neat code. If the code is neat, then what you will see is, you will see that when you run the code, you will have a nice flow of output actually. Okay, so employee name, employee number. So no problem. Yeah, so I'm just trying to match the format so that it looks slightly more neat. All right. So far so good. We have done the employee name and number. We'll move to the next step. In the next step, we are going to display the address, right? The goal was to display the address. So address is simple. We want to do address. So address of employee ID, right? This is what we wanted to display, employee ID. So we can say that address of for shortcut we'll write employee ID. Okay, so what is the address? Address is always printed. So we have to fill up this percentage. You can think for 2 minutes what we should fill in on the address. E dot employee ID. Okay, so any idea what we should fill in here? Any address. So we are putting an ampersand here. Any address. In C language, we can always use %p. %p is the only one which is the perfectly valid format. It will display the address in a hexadecimal notation. Okay, address of employee ID, and then same thing, employee name. So we will display both of them. Name is basically the array, right? So employee name. That's it. So when you look into this, you will see the addresses. Okay, so let me compile this once again. We'll see the compilation is good or not. Okay, so I am compiling this code. Yes, it is fine. Enter the employee number 100. Employee name is Manish. So employee ID is 100. Employee name is Manish. This is good. Similarly, address. Now, very interesting thing here. Okay, these addresses, when you look at it, it says 7FF, CE, and something like that. Okay. On a 32-bit environment, on a 64-bit environment today on a Linux, we have address boundaries. Okay, so when you see that address boundary for a segment, stack segment, this address is coming from the stack. Okay, why? I know the address. Okay, it's 7FFCE. So the machine that I'm using today is our x86 64. It's a 64-bit hardware, right? It's a 64-bit hardware, 64-bit platform, right? Okay. In this platform, what you see is in this platform, the stack is around 128 gigabytes as on today in the year 2021. Sorry. Okay. Yeah. So what you see here is, you see 7 followed by so many FFs, right? So just replace it with F, replace it with 8. Okay, so it's 8 zeros. So many zeros are there. 4, 5, 6, 7, 8, 9, 10, 11, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So you can put lot of zeros here. Right, I am not counting it really here, but it is just replace this 7 by 8 and then put so many zeros. So this is the upper address associated with the stack for this particular program. It is just below that. Okay, so this address is really coming from a stack section or a stack segment. Okay, if you look into this program, remember this is a local variable, and C programming rules says that local variables are automatic variables and then they are always on the stack. So this is how we validate also. We already know from programming this is stack. When you print it, you see it's a very big number, 7FF, followed by so many zeros or whatever, right? Basically, so it's towards the stack side. Another interesting observation is when you run this code again. So you do a dot out again. So employee number is say 101, again Manish. You will notice that these addresses are not constant. These addresses have changed now, because when we run the code n number of times again and again, the addresses that we get from the system are always different. It's not fixed, right? So we'll always say when you run it, you'll always see that it is different. The next one is just to change the track and then try to understand. Suppose I make this struct as a global variable, right? So I'm going to make it as a global variable. So suppose this is a global variable. What do you see? We'll compile this. We'll try to get some good addresses, right? So we'll do a compilation on this. Compiled it, a.out. Enter the employee number 100, Manish. It printed like this, but all of a sudden what you see is this 7FF becomes 5565, 5565. So it is pretty low in terms of, address with respect to this. No, definitely this is a high address. This is a very high address. Okay. But the difference when you see is humongous. Now you have again on a 64-bit platform, right? Somewhere data segments or data sections are somewhere here. Okay. What you will see is essentially employee E. This variable is now coming from the data segment. Let's move on and then try to understand more about the sizes, right? So far we talked about address. Address is coming from code or data. Coming from code or data or stack. So the next one is the size of, right? So we are talking about how much memory is being allocated for this. So as you know that this is an integer. So one of the possible answers is, integers we always get 4 bytes because we are requesting for integer. It's a 4 byte of memory allocation. The second one is a character. It's a character array of 30 bytes. So we have 30 bytes as you can see here. Okay. So we have 30 bytes here. So I think it's pretty simple, 4 bytes and 34 bytes. This is simplified. It is not necessary that it is going to be like this. Okay. Let's see what the system prints it. You have a concept of padding, which I will cover in a separate video because we have to explain with lot of simple examples how padding impacts the size of structure allocation and how to do a no padding based structure also. Okay. So we'll take it differently. Let's quickly jump and then try to display the size. So size of or memory allocated, right? So when you talk about memory bytes, memory allocated in bytes. We wanted to do for employee ID, right? So we want to do an employee ID. How many bytes? Percentage D, or since it's a 64-bit environment, I'm using LD. We don't have to worry. Size of, so E dot employee ID. So I'm just applying the size of this particular employee ID. So show me the real data. In bytes for employee name now, correct? So we're talking about name here. So name. So here we are supplying the name of the array. So when you supply the name of the array, it should show me what's the size. We'll compile this now and then do an a.out. So what you see here is employee ID is 4 bytes and employee name is 30 bytes because that is very clear as far as the program is concerned. We already know that what we demanded. Okay. Now let's quickly look and print the entire size of the in bytes for entire employee record. So we are talking about employee record here, right? The entire employee E. So we are just looking into E. When you compile this code, you will notice that there can be some difference in the size. Ideally, we expected 30 plus 4, 34 bytes for this allocation. Whether the compiler will give me 34 bytes or something different is what we will see in this next run. Okay, so we will do a compilation. I think there's a small problem, typing mistake. We don't have to worry, I repeat. When you run the code, you will realize that yes, there is some issue sometimes when you compile it. So step by step is always good. I was missing one bracket. Okay, so now it is fine. We'll compile this code. So good. We'll run this code now. 100 Manish, right? So what is interesting here is we expected 30 plus 4, 34. It gave 36, right? So as I told you that there is a concept of padding. Okay, so in this particular example, the entire structure employee has to be aligned to a 4-byte boundary. The total size is 30 plus 4, 34, no doubt about it, but 34 is not divisible by 4. So the next higher address, the next higher size which is divisible by 4 is 36. 30 plus 4 is 34. 34 is not divisible. So 35 is not divisible. 36. Yes, 36 is divisible by 6. So compiler has done a concept of padding. He has added some padding of 2 bytes and then gave you a final size of 36. Now the concept of padding I am going to cover in another video because there are lots of examples to show there. Okay, so don't worry about that, it will get covered. The summary of this exercise was to make us understand how to do a live code of a structure. How do we define a structure? How do we use it? How do we get memory addresses in the user, in the stack and in the data section, as well as what are the memory sizes allocated for individual members of the structure as well as entire structure. In the next class, I am going to introduce concept of union, and that is going to be very detailed with a live example in the kernel, and a classical example code will be there. Thank you very much for watching this, and I will see you in the next videos. Thanks for watching the video. We have put important links in the description and the comment section below. If you really enjoyed our video, please press the like button below. We plan to release one video per week. So go ahead and subscribe to Sanfoundry by pressing the subscribe button below and turning on the notification bell.